Hello everybody, this is NTI day 21. My laptop is a little bit low on battery and I don't have the charger and I'm too lazy to go get it, so I'm going to make this as brief as I can. I'm sure you probably would appreciate that too. You don't want to spend all your day watching these YouTube videos, so let me just cut right to it. Today's lesson is tangents of circles, and if you remember what a tangent is, a tangent line is just a line that if I have a circle right here, a tangent line is just a line that will come across here and then just clip this circle at one single point right there at the point of tangency. So that's what a tangent line is, Josh. I should have put that in the notes as a reminder, but there you go. The first definition that I would like for you to type down or write down is, I would just like to review what a central angle is first. So a central angle is an angle whose vertex, and the vertex again, that's like that's the point of the angle where you actually measure the degrees. An angle whose vertex is located at the center of the circle, whose legs are radii, and again, radii is plural for radius, that just means more than one radius. The center of the circle whose legs are radii intersecting the circle at 2 points. So you might remember me some point last week maybe telling you that in math, whenever we don't know what an angle is, we like to use this Greek letter theta. Looks kind of like that Pokeball. That's what this is. So the central angle is, there's a center of the circle. That's the vertex of the angle, and then the legs intersect the circle at 2 points, A and B. So central angle means it's an angle at the center of the circle. Hopefully that should be kind of easy to remember. The next definition is an inscribed angle, and if I've been beating these terms to death the past couple weeks, I understand that. The point, though, is to make sure that the more you're exposed to something, the more it sticks in your mind. So I'm doing this on purpose. I'm giving you these definitions more than once on purpose. And they're not the exact same every single time. I'm wanting to make sure. It's the same definition, but I'm just trying to maybe change up these definitions just a little bit. That way, I'm trying to make as many people understand what these mean as possible. So I'm just trying to cover multiple different bases. An inscribed angle is an angle inside the circle where the vertex of the angle is on the edge of the circle, or it's on the circumference of the circle. It's on the actual circle itself. And again, if you remember, the inscribed angle is half the size of the central angle that intersects the same 2 points. So here are my two legs. So there's that Pokeball, there's that theta. That means here's my angle right here, and this is inscribed because the vertex. Hopefully you can see what the difference is between these two circles. So here the vertex is in the center, in this center space. Here the angle is actually on the circle itself, and the inscribed angle is going to be half the size of a central angle if the inscribed angle and the central angle both. So for example, if I have some point, I'll just call that point X there. If this central angle, let's just say this is something easy. Let's just say this is 60 degrees. Let's pretend this is 60 degrees. Here, I'll just make that as 60 degrees. An inscribed angle, meaning it's on the edge of the circle intersecting the same 2 points A and B. If this is 60, the inscribed angle is going to be 30. It's going to be half of the central angle. So just a quick review on central and inscribed angles. I know I went through that kind of fast, but again, this is a video. You can pause it and rewind it, pause it, rewind it. This is a new definition. This is a circumscribed angle. So we have a central angle, we have an inscribed angle, now we have a circumscribed angle. Let's don't pay attention to this stuff. I tried to draw a circumscribed angle, but it was kind of cluttered over here, so we'll just focus on this part over here. A circumscribed angle is an angle made by two intersecting tangent lines of a circle. So here we have this tangent line. So if this point A is a point of tangency. So AC is a tangent line going this way, and then BC is another tangent line of this circle going this way. A circumscribed angle is the angle formed by two tangent lines intersecting. So the circumscribed angle is going to be falling outside of your circle. That's going to be a little bit different because the central angle, this is inside the circle. The inscribed angle is also, it's on the edge, but it's still a part of the circle. It's on the inside of the circle. A circumscribed angle, you can see right here, it's on the outside of the circle because this is where the two tangent lines intersect to form this angle. And again, that's theta. That's this Pokeball is my unknown angle measure. So yeah, this is still a circumscribed angle. It was just a little too small. I was wanting to make it bigger and more clear. But this little piece right here that I scribbled out, that's a circumscribed angle too, because there's a tangent line, and there's where they intersect. So a circumscribed angle, again, is an angle made by two intersecting tangent lines. And I went over at the beginning of the video what a tangent line was, or I reviewed it, because I showed you a few days ago. This is the last part of this video that I want to nail down before stopping this one and moving on to the examples. And I just want to remind you, remember, this was from a previous lesson. I know that it's easy to, especially today, because we're doing a lesson, doing a worksheet, doing a new lesson, doing a new worksheet. So I understand. That's why I'm trying to go through and remind you all of all these things. So remember, a radius of the circle and this is what you need to write in your doc, is a right angle with the tangent line, meaning the two are perpendicular. A radius of the circle forms a right angle with the tangent line. So if this is the center of my circle O right here, a radius is just any segment from the center of the circle to the edge of the circle. So this right here from O to A, that's a radius. And since this is a tangent line, that means this is a right angle. These are right angles. I could draw a radius from O to B. It's a different tangent line, but it's still a tangent line. OB is a different radius than OA, but it's the same, it's the same length. A radius is the same distance all the way around. So this is going to form a right angle right there. So that is very important to keep in mind, that a radius forms a right angle with a tangent line at this point of tangency right here.